Excellent. Well, if you just assume we can monitor the chat and people can't hear me, that would be good. All right. Well, I'm very honored to be the first inaugural presenter of the reboot. Oh boy. Okay. Yeah, that's the darkest screen. Everything else has got a little bit more color. We're good. All right. Well, I don't have a information slide, so I'll just tell you about myself. I'm not a Wisconsin native, if you can tell by the accent, although I've been here 20 plus years now. Started my career as an in-house DBA in SQL Server, I think late 90s. Spent like the first, I looked at LinkedIn today, 17 years I was an in-house DBA. And then I moved to the dark side and did consulting. And I was a consultant for 5 or 6 years through various companies doing SQL Server still. And then 2 years ago today, I had my anniversary, I joined AWS as a solutions architect. As we were just discussing, solutions architect means you know a little bit about a lot of things. And you go, in my role, I'm a specialist. So I am a specialist in the Microsoft stack. So if customers want to talk about, anything on AWS, Active Directory, Windows, SQL Server. And then I specialize in SQL Server, but I talk about lots of other pieces. So today, I was asked to talk about SQL Server on AWS for our relational database service. It's a managed service that we offer. So let's jump in. I've got a lot of slides, so I'm going to talk fast. Let's get to where are we at here? Oh, yeah. So the agenda says Q&A at the end. I just put that on there for a placeholder. If you don't ask any questions till the end, I failed miserably. So feel free to jump in. If there's a slide that covers it later on, I'll just say, hold your horses. I got a slide that covers that. So let's jump in. So today, I'm going to talk about, this is kind of the presentation we give customers, what's RDS all about, why would I want to do this versus running it on Windows, our EC2, which is our Windows component. I guess just a quick survey. Who's running anything in AWS today? It's kind of a show of hands. Cool. And then, is that AWS or a different cloud provider? AWS? Oh, I did. Thank you. I was going to say cloud, then I changed it at the last second. Somebody's listening. That's excellent. All right, so we got a little bit of AWS. So if I use an acronym, just call me out and say, what does that mean? I'll try and spell that out. So we're going to talk about, if you're looking to do SQL Server in the cloud and you're looking to use our relational database service, what are the choices I want to make sure I can get performance, I can do it cost effectively, and what are all the pieces that need to come together to put that infrastructure into place. So we're going to talk about storage, the EC2, the instance, how much compute, how much RAM. We have a whole different set of families, so we'll talk about that. HA and DR. In the world of RDS, that's a pretty simple conversation because as a managed solution, we take a lot of the complexities away from you. And then we'll talk about how do we authenticate? Do we use Windows? Do we want to use SQL authentication? And then just the basics, how do we deploy it? How do we manage it, etc. So let's jump into that deck and let's go through this. So the right service. So this is one of the few times we'll talk about EC2 as well, just as a kind of a compare and contrast. So RDS, like I said, it's our managed service. EC2 is basically if you think of a VM, that's really the easiest analogy. You got a VM, you got Windows installed in there. Everything else is up to you. So if you want to install SQL Server, you want to figure out how to configure your storage. EC2, you do all that yourself. So RDS is kind of the reverse, where you have a lot of that stuff. If you want to configure high availability, it's a click of a mouse versus building the Windows cluster yourself. So managed infrastructure, managed SQL Server, managed patching, managed backups. We'll jump into this stuff in more detail. And then managed high availability and scalability and such. EC2, some of it's obviously we're still providing the physical boxes that you're running on the hosts. But as soon as you get kind of the OS built, we got a problem.
I'm going to move the camera slightly because you are.
Oh, I'm going to move around, but no, I can stand wherever you want me to.
Oh, that's fine.
So anyway, yeah. So as I was saying, EC2. Once you get to the point if I have an operating system installed, move over here and screw it all up, then you're kind of on your own, which is a good thing and a bad thing. Generally, if you want more complexity, that's where EC2 comes in. If you want to have a simplified version, that's where RDS comes in. So, alrighty. So this is going to talk more about why we'd want to do this at a high level. Typically, if you've got a company that doesn't have any DBAs, maybe you're a heavy Oracle shop, and you've got this one lone application that needs SQL Server, and you don't want to hire a SQL Server DBA to manage it. That might be a good use case. Or you've got a whole bunch of DBAs. They're running 1,000 miles an hour. They're putting out fires every day. They want to have less of that. The things that they do every day that I always call important but not customer impactful. So backups. As DBAs, we care a great deal about backups. The end user, unless they actually need them, they could care one iota about backups until they need them. So that's the kind of stuff where if you're doing a managed service, you can take some of that, taking care of the data backups, taking care of doing the OS patching, cumulative updates, SQL service packs if they still exist. All that kind of stuff can be taken off the DBA's hands to free the DBA up for what I call customer impactful. So you're working with the application team on making something faster, implementing new functionality that requires new schema, you're re-indexing, all the things that the customers will see an impact from. You can focus your DBA's time on that kind of stuff versus installing clusters and taking backups and those kind of fun and games. So how does that really look? Yeah, so business value tasks, high value tuning, the customer impactful, kind of like you talked about. Schema optimization, it says no in-house database expertise. I put that with a caveat. SQL Server will run for a long time without any extra configurations, but eventually it will fall over. It does need a little care and feeding. It's a managed service, but we don't manage your end data. So if you need to run an index or a reindex or update your stats, that's still something you got to do in RDS. You still have access to the agent jobs. You're still going to want to create those index jobs. We have customers that have made the assumption incorrectly that it takes care of everything, and then they'll run fine for a while, and then all of a sudden, my performance is really suffering. Why is that? Because you didn't move your indexing jobs across, and it creeps on for a while, but eventually it fell over. So not a complete shop. Every time it's your data, we don't want to make assumptions about what's the best manner to index your database, what's the most appropriate CheckDB schedule. So that kind of user data maintenance is still part of your DBA's responsibility, even in a managed service. Some of the reasons that RDS may not be a good fit, some of the more obvious ones, you don't have things like a sysadmin role. Because it's a managed service, I always say we're trying very hard to prevent customers from dropping a rock on their feet. So things that you can get into a lot of trouble, like having local administrator on the operating system or a sysadmin, you don't have access to those roles in a managed service. We expose nearly all the security you need for database operations, creating users, all that kind of stuff. But the really nuts, the real deep access that potentially could cause a server to keel over, we don't allow the access so we can meet our managed commitment to you. So if you have an application that has to have sysadmin, that may be a reason why RDS may not be a good fit. But we'll jump into some more kind of pros and cons of what RDS may or may not be a good fit for. But this is just kind of a nice visual of basically everything I already said. On the left side, you'll see that we're covering all the way from power up to scaling. Scaling in this context is really, making the machine bigger, more vCPUs, more memory, more storage. It's not like scaling it out. That's a different animal. And on the EC2, obviously, we're taking care of the basics, OS and such, but then you're on your own. You have a question, Nish? Yeah. And go ahead. Correct. Yeah. Yes. Yes. No, it does, but in a limited fashion. So yeah, we can talk about that. So basically, yeah, it does have agent, but in the world of SQL Server, you're used. Sorry, and the people on the call, did you hear that question? No, yeah. Yeah. So the question was, the question was EC2. It's a SQL instance, so it has a SQL agent that you're used to today. Does RDS have that agent? And it does have the SQL agent you're used to. But if there's various different types of jobs you can create. There's the replication jobs. There's all kinds of other ones. You're really only limited to the transactional SQL job type. So you can create a job that's going to fire for tsql command, run a backup, but you can't create a job that's going to fire for PowerShell command. Going back to that managed service, we don't expose XP command shell. So those kind of job tasks are not allowed inside the agent. But like running a tsql command to run a backup, run a reindex, do some kind of data manipulation, that can all be run through the. Yes. Yeah. totally. Okay, good question. Alrighty, keep them coming. So some of the quick run through of some of these are the biggest hitters as to why RDS may or may not be a good fit. So going down the top, licensing. I don't know if you all manage your own licenses or hopefully it's somebody else's job, not your own, but it's painful and it's expensive. In the world of RDS, the only model we can offer is license included. What that means is when you decide on what EC2 type you need and such, you've got a rate per second. The minimum billing time is a minute, but we calculate per second. And that makes up your actual physical cost for the compute, your CPU, your memory. But there's also a component for your Windows license and a component for your SQL Server license. And we'll talk about which editions you can have. But that's per second. So if you've got a RDS dev box that you want to power on at 8 a.m., shut down at 5 p.m., and it's off the rest of the time, so you're only using it for roughly a third of your business day, you're only paying a third of those costs, versus a box that's sitting 24/7. So there can be cost savings there. Most databases need to run 24/7. I know that, but there are some scenarios for dev environments perhaps where you can leverage that kind of thing. Or if you have environments that you only need for load testing once a month or performance releases, those kind of environments potentially can sit idle for 28 of the 30 days kind of thing. So there's some opportunities there, license included. Easy to just kind of complete the arc. We also include the license included, but there's also a bring your own license option. So which is generally if you own licenses, that's by far the cheapest path is to go bring your own license. If you have software assurance, that helps. If you don't, you can still bring them. Just kind of limits how we can host that software. But you can do bring your own licenses in EC2 or do license included if you don't own any license, so you've been leasing from somebody else in EC2 or RDS. You got a question?
One thing I'm curious about, so I've run SSAS Tabular on Azure.
Mm-hmm.
I run Azure SQL Database on Azure. Azure SQL Database is like incredibly cheap, right? It doesn't generally come with any additional services, just the database. But SSAS Tabular on Azure is very expensive. So I'm wondering like how the pricing works, given that you're offering the whole license package, right?
Yeah. Did that question get picked up by the online? No. Okay. So the question was interested in the components and. Oh, that's all right. So the question was, how do the component services work from a cost standpoint? Oh, it's all right. I can repeat questions. It's not a big deal. So the question was, yeah, the component services like SSAS, Tabular, for example, super expensive in Azure. I'm not an Azure expert, but we can talk about that. I'm just going to keep going through the slide and I'll get to that at the bottom just to keep my momentum going here, but we'll touch on that. So yeah, so now the next thing that can be a critical part of whether RDS is going to work for you or not is the version supported. Because of the licensing restrictions we're working with in Microsoft, we're only allowed to offer versions that Microsoft still supports. So 2008 R2 is no longer offered through RDS. 2 years ago it was, but as it rolled off the supported list from Microsoft, it rolled off RDS also. That doesn't mean that 5 years from now, if you're running 2014 or whatever the expiration date, 2012 should be on there as well. I don't know why they've taken 2012 off that slide. 2012 is still all supported for RDS, but eventually, that's going away in the near future in quotation marks. That will be grandfathered in. If you have RDS on 2012 and then 5 years from now, Microsoft stops supporting RDS, it's a moving forward model. So you'd still be able to run that environment on 2012. You wouldn't be required to upgrade. You'd obviously be missing service packs and security updates from Microsoft, but we wouldn't say, okay, you have to migrate. You can still have that, but obviously moving to supported models is important for many other reasons apart from RDS. So that's the RDS model. On the EC2, basically all with an asterisk. If you can find, a version of Windows that will run in Amazon that have AWS, excuse me, that has the right binaries to run SQL 2000, SQL 7, you can run it. But that's where they start, because eventually the hardware won't keep up with that. If it's a 32-bit operating system, it's a little tougher to compile. But conceptually, if you can find the Windows image that will run, you can do it. If you already have like a VM running an old version, you can kind of take an image of that VM, upload that right into AWS and run it as is. So you can do it, but just a little more complicated. The big thing here that I want to make sure people understand is editions that are supported. There's a big one missing, and I'm not saying the BI edition because I don't consider that a big one, but developer edition is missing. And that's a pretty important thing, because if you've got any kind of large environment or small, you're probably not paying for your development environments. You're using MSDN licenses, you're using Developer Edition, whatever, depending what versions you're running. So RDS doesn't have a Developer Edition option. Express, Web, Standard, Enterprise are all there. What that means is, I tell most customers a hybrid solution is best. If you have a need for a development environment, run it on EC2. Then you can use Developer Edition. That's the way to go. If you have to have like a performance, like a load testing environment, that's where you may want to run it on RDS, and that's where the conversation about shutting RDS down when you don't need it to save money. But that's really the scenario where RDS load testing should match production, but for lower environments where you don't really need it to match apples to apples performance-wise, use EC2 for your Developer Edition. It's going to be far cheaper than incurring all that additional licensing costs for your dev environments. Okay, you go first, you go second, go ahead.
Looking at encryption. So basically, like if you look at 27, a lot of stuff. Basically, TDE, I think, is enterprise only.
Not after 2019. 2019 it became standard.
2019
Standard edition.
I guess my question is if AWS has encryption.
Depends what business case, what your requirements are. We can chalk on that in a couple of seconds.
Because I was thinking, well.
Yeah, no, some customers don't. Yeah. Right. Yeah, the question was, you have all kinds of encryption options. Do I need TDE anymore? And the answer is always, it depends. Sorry, you had a question also? Or?
No, I thought you had one.
Oh, sorry, I thought you had a question. No, we're all good. Okay, so yeah, so let's, we'll get to that in a second. So yeah, Developer Edition is something to be aware of if you're looking to consider any kind of an RDS. The EC2 is still the best platform for your development environments. And if you're trying to simplify if you're trying to get away from managing Windows boxes, you can stack you can do a multi-instance installs. You could have 10 dev instances all on the same box. Just kind of keep your footprint as small as possible. It'll take forever to patch them, but just to kind of one footprint of that EC2 box running a bunch of dev environments on Developer Edition, that's an option. And then high availability, we have a slide, so we'll kind of jump past it. Basically, always on is the one for RDS, but we have other choices too. Now, encryption. So the question was earlier, TDE. So up till 2017, that was an enterprise-only feature. On SQL 2019, they finally made it a standard edition. So why would I want to use one, or why would I want to use the other? Because we do have at-rest data encryption through our EBS, which is our elastic block storage, which is our virtualized storage tier, but you can attach to our managed service. RDS and EC2 both run on the same compute nodes behind the scenes. There's no smoke and mirrors there. It's the same thing. TDE solves some other, because it's at rest. There are some requirements, some organizations require, they don't want to say you're encrypted. They say, we want you to use TDE. If your compliance folks says that having the data encrypted at rest is good enough, that might be okay. It's not apples to apples. There are additional things that TDE are going to give you that just encrypting the drive isn't going to get you there. RDS has some additional limitations. Sound like some people use TDE today? Yeah. So some of the limitations today with transparent data encryption in the world of RDS is you can't bring your own keys from on-prem into RDS. You can EC2, but RDS, because it's that, again, you don't have access to the operating system. If you have a database that you need to have transparent data encryption in RDS, you basically have to unencrypt it on-prem, back it up, carefully move it into RDS, and then re-enable TDE, which can be a lengthy and painful process. But if it's where you have to be, it is supported. And then the reverse of that, if you have to take it out and put it back on either an EC2 box or take it back to on-prem for some other reason, you'd have to de-encrypt it and then move it unencrypted, because again, we can't get the keys as of right now in and out of RDS. So it's a little more complicated. EC2 works just as you would expect. You can bring your keys in and such, but RDS has got a few limitations right now with TDE. But anyway, so yeah, if you use TDE, it's worth a conversation with your support people if you want to see how that really works. Yeah, I could talk for a long time about that, but let's keep moving forward. Windows and SQL authentication. RDS is only supported through our managed AD. Behind the scenes, it's just Windows Active Directory running, but kind of the same concept as provide a managed database service. we're providing a managed Active Directory. So, you provision it, but you don't worry about patching it, configuring Active Directory, all that kind of fun stuff. So you can do things so you can do Windows authentication, you can do SQL Server authentication. So same things you're used to today can work just fine. And then backups, we'll talk a little bit more about those, but we have automated solutions. And then patching is, again, automated. You go at the console says, hey, there's a new version, a new CU, maybe a new service pack for the older versions. Do you want to apply that? It doesn't force you. You don't come in on a Tuesday and find out that all your production boxes got patched to a new release without you knowing about it. That doesn't happen. You can go in and say, okay, let's patch all our dev boxes so we can get some regression testing done. And then next month, let's patch production. But instead of having to sit there and run setup.exe, it's taken care of for you. You can say, let's run it on the next scheduled backup or, scheduled maintenance window. So you want to make sure it compile, you'll check the outcome of the patch, but you don't have to sit there and run the patch yourself. You just have to watch your alerts to see if anything happened. But obviously, if you're running RDS, you're going to hopefully have high availability, and then we're not patching both at the same time. So the same kind of support structure of having a passive node and an active node, not patching both at the same time, that's still put into place. So you have some protection for strategies for patching production. We'll talk more about those in later slides. Component services, let's touch on that quick. So basically, RDS, let's say for the sake of number, RDS costs $10 an hour. I'm completely making up a number. What you're providing for there is a Windows installation. It's got an instance of SQL Server running on it, and that's that $10 an hour. But by that, you've exposed a licensed copy of SQL Server. So if this was an on-prem box and you wanted to put analysis services on the same box, you don't have any more license costs. You don't have any more Windows license costs. You just put it on there. Whether you have enough horsepower to make it performant is a different conversation. And that's what we're doing with RDS. So if you enable analysis services or integration services or reporting services, we're basically going in and adding that additional service to the same Windows installation. So there's no additional Windows license. There's no additional SQL Server licensing because once you license that box, it's covered for all the components. And they're there in the same place. You may have to increase the performance of the hardware to keep up with your needs. And you may have to separate them out for other reasons. But from a just cost dollars and cents standpoint, once you put that component on that machine, it's using the same license you're already paying for. So we keep it that way. So there's really no additional costs for running specific components on RDS. So it sounds like other companies do different things, but that's how we do it.
So in that scenario, they compete for resources. The resources are allocated and they compete for them.
I mean, you can go in and set the memory analysis services and set the memory of the instance. If you've got a large enough box, and that's where it's, if I need to spin up a box that has, 128 cores to give it enough horsepower, is it going to be more efficient to run 2 boxes of 64 cores and have SQL and analysis services doing their own things? Then you've got to do a, cost analysis, which is the cheaper of the two. But if it's for a dev environment and you just want analysis service, something like that, you can still use developer edition for that example. But you know what I mean? If you don't need a whole lot of performance, you just need to have a reporting services environment. That's probably a better example than analysis services because the needs are less. But yeah, it appears in the same box, so there's no additional cost unless you need to increase the performance to keep up with the dual requests for load in that box now.
And can you scale it automatically on a schedule?
Yes.
RDS instance?
Yes, yeah. You can basically, we expose our Power CLI, or you could PowerShell, whatever your language of choice is, Python, Lambda, you can do all kinds of fun and games. Yeah, you can have it go in and say, 8 p.m., scale up my box, run my analysis services workloads overnight, build my cube, whatever. And then 5 a.m., shut it back down to a smaller, not shut it down, make it smaller. It does require an outage to scale it up and down. So there is that to come through, but you can scale up and down, and people do that. They want it hot during the day for user databases. They're on a different tier at night for their after hours, analysis services, rebuilds, whatever, cubes and such. So that's an option. Gets a little more complicated, but yeah, that's the beauty of the cloud. You can make things much bigger and then much smaller. If you got a month-end cube, you got to rebuild or something like that, you could jack up the CPU and memory for that couple of days, and then once it's there, bring it back down, or
right.
Or monitor, if I'm basing my workload on flat files hitting an FTP site, and all of a sudden I've got 50,000 more than I expected, that triggers a command that says I need a bigger box for the next 6 hours until we keep up with that. There's probably better ways to deal with that exact scenario, but that's just an example of you've got a pretty user-driven, automated as much as you want. You can use PowerShell, you can use other commands to make it based on external influences to decide how big you want it to make it, when you want it to go up. Kind of like load balancing, but obviously not a web tier, it's an app database tier.
And then like, since SSIS cannot do operating system tasks, you couldn't like create an ETL job in the middle of which you would scale up the instance.
Correct. Yeah. So that's enough. Yeah. So in I always call these like kind of V1 implementations. Reporting services is pretty solid. The only thing it's missing is the ability to create that scale farm in reporting services. Everything else is pretty much there, except for the ability to, if you have a report that needs to run against an Oracle database, so you need a custom ODBC driver. Because you don't have access to the operating system in RDS, you don't have access to put an additional ODBC driver in there, so the report can't go talk to an AS400 or an Oracle database or something. But SSRS pretty much is there. And integration services, because it's ETL, again, you have the same limitations about ODBC drivers. So I kind of call it a V1. If you have complex, I consider complex where you're doing things like going out to an FTP site, pulling a file down, unzipping it, massaging it, then throwing it into an ETL process, and then at the end doing the reverse, zipping it up, pushing it back to somewhere else, moving it to a different server. What I was considered normal SSIS functionality, that isn't supported. And the workaround that's been around for a long time is, again, run an EC2, fully functioning SSIS. But you can run your databases on RDS and just have the SSIS service running on RDS on side. But you know what I mean?
So same question about the EC2 instance. Can your SSIS job on an EC2 instance scale the EC2 instance?
Yes.
And then like if there's an outage, does that mean your SSIS job dies? So you have to kick off the next phase of it, or can it continue after scale down or scale up?
That's however you want. If you want to build flags in your database that says, okay, this piece, and I have the job. When your server wakes up, check a flag outside of SSIS. Do I need to pick up where I left off? Do I need to restart? That's all the logic you can build. EC2 is whatever you can do today, you can do in there.
Okay.
And just plug in the CLI code to do the automated stuff within the AWS console as well. Everything you can do in the AWS console is API driven, and we expose all that through the command line too. So everything you can do in the console, you can do in the command line. If you're using like CloudFormation is our infrastructure as a script kind of solution, or if you're using Terraform, all those tools can be done with RDS as well for automating that kind of stuff. Great. Let's good conversation. So this is basically a summary of what we really just talked about. So I'm just going to kind of skip over that. I can share a PDF of this script of this deck at the end as well if people want to take that away, so they don't have to take too many notes.
Could you go back to the?
Whoa, that's you.
So what's that mad part?
You have to mute yourself, I think. Yeah, I'll talk about that on a later slide, but yeah, we'll get to there. So this is basically just kind of giving you a list of things that RDS does not support. And in reality, this link is what you should really pay attention to at the bottom of the screen, because this is an ever-changing. I'm going to show you a slide about things that are being implemented in RDS on almost a weekly or monthly basis. So there's a few things here. Resource governor probably isn't a big deal for most companies. It's a big deal for some. Broker endpoints, that's a bigger deal for some customers. File stream is kind of a thing for some. So there are pieces. It's not a complete solution, and that's kind of the trade-off between a managed solution and a EC2 self-managed solution. But this is kind of giving you a list of things that are not supported. And this is it. This list is always changing. So that's just be aware of these things. If there are things that are on this list, like replication is kind of should have an asterisk by it, transactional replication, because we do support RDS as a subscriber, part of a push subscription. So if you wanted to have an additional subscriber that's RDS, make it a push subscription, you can have that go to RDS. So you can use RDS in the context of replication in some respects, but you can't create publishers, you can't create the distribution database, things like that. So that's a list. Stretch databases, that's more of a Microsoft thing anyway. So let's say it's not a complete list. That link is the one to take away, because that'll tell you as a kind of a real time what's out there. If there's something that's, you've got 100 customers that would use it tomorrow, if you had that, if you have an AWS account manager or something, let them know, because one of the roles as a solutions architect is to take requests back to the service team and say, I've had 50 customers in the last month asked for this one feature in RDS. Let's push it up the, priority list. Because, that's happened. I've done that firsthand myself. So this is just kind of I'm not going to read through this whole, why is it? Oh, I don't know why that thing's hidden at the top there. Basically, it's saying rate of innovation. This is all the stuff that was pushed out in 2020. Not going to go through the whole list. Database mail is probably a big one. Read replicas, like we said, all the component services, distributed transaction coordinator. So managed AD. So a lot of things in there. This is mostly to show you that this is not a static feature. It's evolving. This is a 2021 list so far. Always standard edition, always on was a huge release for RDS, standard events. And we'll talk more about the R5D and the M5D in a couple of slides. But that's just kind of give you an idea of the evolution and how it's continuing to add features again as customers come to us and say, we want this feature, it would make RDS work for us. So this is just talking about some of the toolings, Management Studio, SQL Command. Most of the tools that you're using today to manage your database, you can do today with RDS. Third-party products, as long as they don't need sysadmin and they connect to 1433, you're pretty good to point those at your RDS instances too. 100 databases per RDS instance. That's kind of driven because we're using snapshots behind the scenes, because if we're using high availability, it's always on availability groups, and there's a 100 database soft limit in the Microsoft documentation. So because it's a managed service, we've made that a hard limit. So if you try and restore 101 databases, you'll get an error that says this database can only support 100. And there are instance sizing. So if you want to go to 100 databases, you'll need to run a larger instance to keep up with the replication requirements. So if you've got 500 databases, we have other means of hosting SQL Server that would do that. RDS isn't the right fit for lots and lots of databases. But we can do failover cluster instances and things like that that can. Like I said, you don't have local. Yes, so it's the SQL instance. So when you deploy RDS, you're basically in a Windows box with a single instance of SQL Server deployed on it, and we're exposing that. We give you like an endpoint, fully qualified to get to that endpoint, and that just exposes that single instance. Are you able to do? Yes, you can do link servers back to others.
I think the equivalent is the Azure SQL managed instance, as opposed to Azure SQL database.
Yeah, but you can also do link servers if you want to go that route back to other SQL Server. So yeah, you can get there. Don't be stealing my thunder. Yeah. And maintenance plans are not supported, which I don't lose any sleep over, but your mileage may vary. But yeah, you can put Hallengren scripts out there. I don't know if Menuware would run on RDS. I have not tried that, but like Hallengren's is probably the more frequently used set of scripts. And you've got to tweak the backup piece. I think there's some GitHubs out there that people have done that conversion already, but most of it works just fine. You have to do a tweak on the backup scenario, because in RDS we use custom backup store procedure, which we'll talk about in a second. So basically the short answer is that most of the tools you use today, the most common Microsoft tools, will all work just fine with RDS. So selecting the right instance, basically when we say instance here, we're talking about how many CPUs you need, how much memory you need, how fast you need the storage to be. And network performance typically isn't as critical, because you're not generally using the NIC for a whole lot of anything. If you do SSO, typically you don't have access to the operating system. And I've said that a few times in part of the managed solution. The only scenario where that isn't true is if you put SSIS on RDS, it creates a single directory called, I think it's DSSIS or something. And you're allowed to access that directory to upload files and download files for ETL workloads for pushing files up and down. So that scenario, you might care about your network performance. Typically, RDS is not as critical. So these are the 4 areas, excuse me. And how do we put that together? So this is by no means our complete list of all the different EC2 instance sizes we offer. This is more focused on database. Typically, we're broken down into 4 classes. General purpose, okay for dev boxes. I generally don't recommend it for database workloads. You don't want your developers to be sat waiting on something to spit up. It's not a good use of their salary. Compute optimized, if you're doing heavy analysis services or compute-driven operations, that may be a good fit. Typically, the two areas where we do see most customers go are the storage optimized and the memory optimized. Memory optimized, just as it sounds, because it's not like VMware where you can say, okay, you know, this box needs 4 more cores, but that's it. Or it needs an extra 20 gig of memory, but that's it. You don't have that flexibility in AWS. So if you need to go from, you know, 64 gig of memory to 128 gig of memory, you're picking the next size up, and that's going to come with double the cores as well. So, and in RDS, because you're paying license included, you're going to have, you know, more license costs, which can get expensive. So what you have to do then is decide what's the correct ratio. And in our memory optimized, we expose the most amount of memory for the least amount of cores, if that makes sense. And our compute optimized is kind of the reverse. You get more cores per gig. In the memory optimized, you get more gig per core, if that makes more sense. So this is kind of the most common footprint for database workloads, that memory optimized. If you need different storage options, this iSeries have a ton of local storage attached, and we'll kind of talk about that in the storage section. But this is kind of giving you, it looks complicated. Really, the things you need to take aware are memory optimized, and you know, generally the R5s are our kind of go-to instance size for most database workloads. That's kind of the sweet spot. If you need faster cores, you go to our Z series. If you want slower cores but more memory, you go to our X1 E series. So there's a lot to it. I can't probably do it all justice today, but understand we have a whole slew of choices to hopefully allow you to kind of tune in your compute needs to the right workload. And you can pick a different one for each environment. You know, one might be heavy compute, one might be heavy memory. So just an idea of that, how that looks. Now, that's the compute, and once you've kind of got past that, you need to figure out what else can I do. Now, the nice thing here is, like we said, you can scale up and scale down. You can go as small as 2 cores, 2 gig of memory, if it's just a machine that you need to be there, but you don't need it to have a whole ton of horsepower for most of the month. And then end of month, you need it to take a bunch of workload, scale it up, and then come January 2nd or whatever, you know, first, second of the month, you can scale it back down. And again, compute, you can do the same. Storage, you can scale up, you can't scale back down. It's a one-way path for storage. RDS does offer auto scaling. So if you have, you know, a workload that today needs 5 terabytes, but you're pretty sure you're going to scale it up to 10 terabytes over the next 6 months, you can provision it with 10, but say, I only want 5 to be presented right now, and I want it to auto scale in increments of X up to 10 terabytes. Then you're only paying for 5 day one, but as your storage needs go up, it'll scale up for you. So that's pretty nice. That only supported up to 16 terabytes. If you need more storage than that, we can go up to 64. But as of right now, it removes the ability to do our auto scaling. So currently, if you need it, you can get it provisioned, but it's provisioned as a one-time operation. If you need 32 terabytes, that's what you get. That's what you pay for. If you need more than that, you kind of got to do it's almost like a mini migration to get to a larger. It's a manual process. So if you need more storage, you kind of have to plan ahead. But RDS can go up to 64. 16 allows you to do the auto scaling. And then some of the performance requirements, we're going to talk into that a little bit more. Like I said, R5's up there. X1E's got a ton of memory. Z1D's got a ton of faster cores. So there's a various different means of getting faster machines to run your workloads. We have in some of the, if you see it's like an R5. We used to have an R4, now we have an R5. That's just the version of that instance class. If you see a 5, that means it's our latest revision, and it has our fastest hypervisor, but it also means it typically will have access to our NVMe storage. So NVMe, super fast SSD, it's attached to the host. So it's a great use case for TempDB. It's not persisted, so if you do reboot, the drive goes away. So it doesn't work well for your user databases, but it's a great place for TempDB. So that's offered on EC2. And if you do an R5D or an M5D, it's on a prior slide, that slide I showed you, it flags them. But the 2 instance types, if you pick RDS and that instance type, it automatically provisions that NVMe drive for your TempDB workload, which TempDB, super fast. And we'll talk more about why that's important when we get to storage. So yeah, DB instances can be changed. It can be a reboot to change the, go from a 4x to an 8x. It's generally how we do it, large, extra large, 2x, 4x, 8x. you'll see that's kind of our, and as you go to the next size up, you get more CPU, more memory. If you need to switch those, in RDS, it's either a reboot if it's a single instance. So if you have high availability, it can do a failover, and you can do the, do the passive mode, as it were. So it's still an outage, but it's a much smaller outage because you're doing a failover, not a full reboot. And storage is the same. We'll talk about that on the next slide. Next slide. All right, so EBS, basically it's elastic block storage. It is our kind of virtualized. When I say that, it means it has redundancy already built into it. So every time you have a drive, every time you write a piece of data to that drive, we put that in 3 different places within our availability zone. So if there's a problem with a single drive, behind the scenes, we have 2 of the copies of that drive. So from our data recovery standpoint, you can get to it. It's not by any means fast enough to be a high availability consideration, but it's there from eventually we can get your data back because we have 3 copies of your data. What that means is it's good, but so you don't typically need to do a mirror on an EBS volume because we already have those 3 redundant copies. But you can do striping. So like the typical, RAID 5, RAID 6, it's actually counterproductive to do that in EC2. This isn't actually an RDS option. I'm kind of moving to EC2, and you can do it for different volumes. But anyway, so EBS, you can do the storage. That's the same storage tier behind an EC2 volume or an RDS volume. And there's some drives that are faster than others. And that's kind of going back to that whole list of compute nodes. We have all kinds of documentation on our site that says this specific type can get so many IOPS, so many megabytes of throughput as a capacity. And then you can decide, okay, this database needs so much throughput. I need this instance type to get that amount of storage throughput. So this is how the storage looks for RDS. This is a pretty simple footprint because we only have a couple different storage tiers for RDS. We have our general purpose, which is currently GP2. We do have a newer version of that, GP3, but that's not supported for RDS just yet. And then we have a provisioned, which is IO2. We're good there. Yeah, so IO1, we do have a new version of that, IO2, but that's not supported for RDS yet. Thanks. So then, this is the drives you have to work with in RDS. If you need to system, you pick in a GP2 drive for our general purpose, or you pick in an IO1 for our provision. Provision means you can assign more IOPS per drive. GP2 is more of you add more storage to get more performance. So linear growth versus IO1, it's got a little more, you can add more IOPS. And basically when you provision that, you get a single up to 16 terabyte drive. And that's the one. So that's the thing to understand for RDS is it's a single drive. So your master database, your user databases are all on a single drive in RDS. If you go past 16, behind the scenes, we are striping multiple drives, so you'll get more performance there. But it's still either all GP2 or all provisioned IOPS IO1. So that can be a limiting factor in storage performance in RDS. So again, some of the reasons where you got to look at what your application needs are and see if RDS is a good fit. So that's kind of the thing. And I did have a slide here I wanted to show you. This is the full array of storage options that we offer in AWS, where you have, additional IO2 block space, bunch of other things. You say you'll get these slides if you can look at this. This is all available in EC2, but RDS is just the GP2 and the IO1 currently. I just wanted to show you that so you didn't walk away thinking, well, AWS only has 2 drive types. That sucks. So that's why that slide there. It's more appropriate for EC2, but I want to make sure you had that information. So how does it look for HA? So if you've got a couple options when you deploy an RDS. The most basic option is I need a single instance. I don't need any HA protection. I don't care if it goes down. I don't like my customers. I don't like my developers. And that's what this is right now. It's a single availability zone. Availability zone is one or more data centers that are all attached through low latency, high throughput, dedicated AWS connections. So that's how that works. And a region is made up of multiple availability zones. And these availability zones, because they're low latency, high throughput connections, are appropriate for doing like a synchronous commit from 2 different databases. These availability zones are close enough together to be appropriate for that kind of an architecture. And by that same token, they're close enough together to not really be appropriate for a disaster recovery strategy because they're a little too close. So that's our basic RDS footprint. Single instance on a single machine in a single availability zone, no HA. The next step is if you want to go, yeah, sorry, you got a question?
Coming back, I'm thinking Microsoft, I'm that college student. Microsoft
So right now we're talking a single region. So in AWS you have North. Yeah. Most clouds have that concept. In AWS you have like Virginia, Ohio, California, Oregon. We have all those regions, with these multiple availability zones or multiple locations within. Some regions and other cloud providers will only have like a single presence. We don't publish a region unless it has multiple levels of redundancy in terms of data centers, availability zones. So you can see when you pick a data set, a region in AWS, you'll see how many availability zones it has. An availability zone is multiple data centers. So that's how this kind of comes together. This is so far, you'll see it's a single region so far. This is, Virginia, let's say, US East 1. And then if you pick multi-AZ, that's when we build behind the scenes. This is where we do the automation. We say, I want a multi-availability zone. So behind the scenes, we provision 2 Windows boxes. We build a Windows cluster. We install SQL. We build an availability group on top of that Windows cluster. And we put all the databases. We do the seeding of the databases. We put all that together. And the end product is synchronous commit, automatic failover. And all you did is pick a radio button on the web page and hit build that. So no, this is a single region so far. This is two availability zones in a single region. So they're both in North Virginia, but in different data sets. Yeah, you'll see that in a second. So this is kind of how it looks, multi-AZ, and this is always on availability groups behind the scenes. If you use an old version like 2012, it'll do mirroring behind the scenes. Just depends on the version and edition you select. But at the end of the day, you still get synchronous commit, automatic failover. So you don't really care if it's mirroring or always on availability groups, in as much as you get the same HA protection. Just, that's how we have to build it, depending on the version and edition you pick. Now, so that's giving you HA. The other thing you can do is if you want to do a read replica, this is still a single region concept. We don't have straightforward DR right now, and I'm going to talk about that on the next slide. But you'll see here, if you want to put a read replica, you can create a third copy of your data, and that's giving you that asynchronous commit, no failover. It's just there for pushing your read workloads to a different copy again. This is all enterprise only because, again, we're using Microsoft tools. So if we want to do a 3-node always on availability group, we need enterprise to do that. It's not offered through standard. This first 2 pieces, we could do a standard edition. We'd use basic availability groups, but we take care of the complexity of having a single availability group for each database, having them all fail over in sequence, all the things you have to do build manually for standard edition and always on availability groups. We take care of all that in RDS. But to do the read replicas, you need to be running Enterprise Edition, which can be expensive. So we do have, and this is just kind of showing you, if you have the multi-AZ, we expose a listener, same concept you're used to already, pointing at your primary copy. One thing to note, this secondary copy is not accessible as a read replica. Typically, if you're doing availability zones, always on availability groups, you can make that second node readable, put traffic there, whatever you want it to do. In RDS, it's purely there as a passive node. It's not there for any read replicas. So if you wanted to have a read copy, you'd do what I did in the prior slide. You have to put a third copy up there. You'd be paying for 3 sets of enterprise licenses. It can get pretty expensive, but it is possible. I have a better solution on the next slide. So yeah, so we have the listener pointing at a primary node. That fails, either planned or unplanned. Now your listener automatically moves over there. As long as your application's got retry logic, it should be transparent to your application. Hopefully all your applications have retry logic and they don't just blow up if the application fails over. Touch wood. So that's what's happening. And then after we do that, automatically we're going to provision a new RDS environment behind the scenes, do all the building, the seeding of the databases. And then eventually, when that gets to there, it'll be promoted back to primary. And your listener will move back to the primary copy as you kind of configure maintenance windows. So that's kind of the life cycle, just as you'd expect it to work. Just the only difference is that passive node is not accessible for read traffic, and behind the scenes we are kind of moving things around for you. Now, like I said, that's all enterprise. That can get pretty pricey. We do have other options. There's it's not an AWS product, but we have a marketplace that's got a whole slew of other vendors that put products. They pre-configure their applications to run in AWS, and you can go into the marketplace, pick their product, pay them for it, and they just give you a pre-packaged image to run in AWS. Cloud Basic is one example. So not an AWS company, just an example of a marketplace. This allows you to do CDC replication of your data, but it's not driven by enterprise. So you could do all this on standard. So here we have putting multi-region. So we couldn't do that in RDS. We had enterprise to get to that point of having to read replica. This could all be done in standard edition. We have 2 different nodes running in 2 different regions. And where this is obviously going to be, I'd recommend asynchronous because it's going across region, but this is another way of using RDS in conjunction with something like a Cloud Basic to get a standard edition version of your environment without having to pay for the enterprise licensing. Or if you wanted to have, enterprise as your primary copy, but you wanted to have 3 different replicas that are all subsets of the data, you could do all 3 subsets as standard and have your primary copy as enterprise. And there's no, because it's not a Microsoft always-on replica concept, it's just using CDC behind the scenes. You can have those read replicas. This one could be enterprise. These 2 could be standard. You can kind of build it all up as much as you want. This could probably be Linux if you were so inclined. So it gives you much more flexibility in your licensing and how you configure across region in the same region. And that's Cloud Basics. It's just and one example. There are others out there, but just a way of using other tools to be smarter with your licensing. So, I know we're getting close to time here. Active Directory, basically, real simple. We have our managed Active Directory, MAD. Not an acronym we pick. We did pick it, but we don't use it. Basically, that is a fully Active Directory. You can spin one of those up in AWS, attach your RDS environment, and that gives you Active Directory authentication. That works great if that's where you live. If more likely you're on-prem and you already have Active Directory running for your corporate environment, the next scenario is much more like it, where you basically have your Active Directory running on-prem. You use this managed Active Directory in AWS, and you create a trust relationship. The end product is your Active Directory account you're using corporate today can be used to authenticate to RDS through this configuration. We have lots and lots of customers doing this. This is by far the most common way to use Active Directory with RDS if you want to maintain your on-prem Active Directory. So I'm going to pick up the pace a little bit here. So how can we deploy it? Like I said, that console is all driven by APIs. So we have our infrastructure scripting, software development kits, our command line interface, our CLI, and the console itself. They're all driven by the same APIs behind the scenes. So this is just an example of, this is PowerShell. This is if we wanted to deploy, if we wanted to deploy using this, we could just, that first block says what kind of instance we need. Second block says the security we need and such, versions we want, additions we want. We can just build up this command, run this as a single instance, or wrap this in a script and run 1,000 versions of this scripting and spin up 1,000 RDS environments. You have great flexibility to use automation to build up your environments and do everything from a command line if you want to automate it. Have runtime scripts for your DR environments, so just to rebuild your environments, runbooks and such. So lots of flexibility in how you build those environments, standardize. Some best practices. Let's see. So the standard stuff, we have monitoring. We have something called Amazon CloudWatch. CloudWatch is basically our internal monitoring tool that talks to a whole slew of AWS services. You can recognize if your CPU is spiking, if your storage is being hit too hard, if something's down. So we can set up custom alerts. So we can actually pull in your SQL Server logs, monitor for like an 832 notification if you have those kind of errors set up. And you can have those specific text matching scripts from the logs fire an alert to your on-call person. So we have that flexibility to parse the logs, look for CPU, storage issues, and fire off those on-call pages to your on-call or whatever. Or go to some custom dashboard you use for monitoring in-house or something like that. So you have lots of flexibility in monitoring. This is just talking about, we have monitoring, we have enhanced monitoring. Enhanced monitoring basically just exposes more metrics, allows you to do more granular customization of how you monitor things. It's kind of the simplest way to put it. And then we also have something called Performance Insights. And this is free. So if you use any kind of a decent third-party monitoring tool, this looks familiar, but much more basic. So every RDS environment you have, you can hook it up to this for no cost. This gives you 7 days of history, and you'll see you've got weights, you've got your performance numbers, you've got your chatty neighbors, you've got your most costly SQL statements. So this is 7 days retention, no charge to you. So it's obviously not as good as a SQL Sentry or any of those other big products. But if you don't need that, or you want something quick and you don't necessarily have access to the monitoring tools because they're a different department of the company, this is a pretty nice starting place to do some troubleshooting. Say 7 days for free. If you want to keep a longer retention, all you pay for is the storage to keep those metrics. No, but the tool itself is free to use. So that's pretty nice if you've got RDS. That's just RDS. That isn't EC2. And then we talked about our backups. So our automated backups, if you spin up RDS in a console, by default, it's going to have these automated backups turned on. These backups are snapshots at the drive level. So they're using VSS, they're using quiescing. So they're, SQL aware snapshots of your drives. And we do one a day as part of that automated configuration with up to a 35-day retention. You could also do manual snapshots. Like if you were going to do a large patch or a new software release, you may want to do an additional manual snap. Or if you want to get past that 35-day retention limitation, you want to do manual snaps, every month end, every quarter end, every fiscal year end. And those stay around forever. If they're a manual, there's no retention time. You just pay for the snap. As part of this, we're doing T-logs every 5 minutes. So you have point-in-time recovery. You can go into RDS and say, okay, go grab that production environment and restore it back to 7:36 yesterday morning. It's actually going to restore the whole RDS environment. It's not a database level restore. It's an instance level restore, which can be a little painful, but it does have that point-in-time recovery, and that's all built into that managed service. So that's a great starting point. But as a DBA, I'm in love with my native backups. I sleep better at night knowing I take native backups. So we also support native backups. These directly write to S3, our trying to think of an acronym for S3. Storage service. It's a super cheap storage. They've got multiple different tiers of storage within S3. So I can think of it as offsite storage that's super cheap and basically unlimited space. So you can do a native backup. You can do a full differential. You cannot do a transaction because you saw we're doing those 5-minute T-logs for our point-in-time recovery service. So you cannot take a T-log backup, but you can take a full and you can take a diff, push those to S3, use Halangren scripts or any in-house custom procs to do your backup strategy. All push those up to S3. And if you wanted to, you could replicate that S3 to a different region and call that your DR strategy. You can also do restores into RDS, and you can do a restore for full, differential, and do we have to get kicked out? Have I got a few minutes? Good. Okay. So you can do a full, a differential, and a T-log into RDS. So if you're looking to do like a migration, you want to kind of do a log shipping approach, we don't support log shipping natively because the wizard is going to assume it's running on, EC2 effectively. But you can, through PowerShell, push your T-logs into an S3 bucket. S3 bucket is does everybody know what S3 is? Okay, so S3, basically, it's a block level storage. You throw a file into the cloud, and it stays there forever. You can lock it down. Super cheap storage. It's basically the modern day version of Iron Mountain. I always like to think of it, instead of shipping your tapes to Iron Mountain every month, or from the data center, this is like doing that, but with unlimited tape storage racks. You know what I mean? It's just a very cheap, massive amount of storage, and that's a great place to put your backups. So you can push your backups from on-prem or from EC2 into S3, and then from there restore it down to RDS. And we do expose a custom store procedure to do the backup and a custom store procedure to do the restore. It does support encryption, but it's not the SP backup. So that's why Halangren scripts don't work out of the box, because you've got to change his SP backup to use our internal AWS backup. Behind the scenes, it's still doing a backup and then firing that data off to S3, but there's a few more hoops to get it into S3. So you do have all the options. You can do what I always call like a hybrid log shipping if you like PowerShell or something like that, just to ship your logs into S3 and then restore them from S3 with no recovery into RDS. All those options are there. And I generally encourage kind of a belt and braces approach. Keep the snapshots on. Understand that is a snapshot, so there is a stun. You'll see your logs IO freeze, IO unfreeze, whatever they call it. So there is some overhead for that. If you're running it once a day at 3 a.m., generally you'll get away with it. I don't recommend running those at 9 a.m. in the morning and the busiest day, because that stun can be painful. But you're taking the same thing if you're doing like any kind of VM snapshot or those kind of things as well. But yeah, doing the native backups in addition to those snapshots is great. Gives you database level recovery right off the bat versus having to restore the whole RDS instance and then go grab the backup you want. So any questions on that part? Because I want to make sure you understand that you do have quite a bit of flexibility in your backup choices, your recovery restore choices in RDS. It's still Microsoft And any backup you take in RDS is a completely normal SQL Server. You can take that same backup and restore in any of your production boxes on-premise, not a custom build of a BAK file. It's the exact same thing you're using today. Obviously, the same restrictions. You can't go from 2014 to 2012. Same rules apply. It's Microsoft. But you can ship that out of your system and use it somewhere else, like a DR strategy to on-prem or something. Yeah, good. Alrighty, where are we at here? We're pretty close. All right, so got here configurations. This is a nice thing. This is basically two different places. Parameter groups, think of it as SP configure. If you want to create like a standard build for your production boxes, using our parameter groups allows you to create a custom SP configure profile. And every time you build a new RDS environment, you can attach this parameter group, but it just makes sure that SP configure matches whatever you want all your production boxes to look like. So that's pretty nice from a standardization standpoint. The option groups is where you enable TDE, MSDTC, the ability to back up to S3, those, components, SSIS. That's how the options groups work. The parameter group, and this is kind of a visual that makes sense. This is a parameter group. You can see, looks like SP configure. Some of these can be applied automatically. Some of these have to require a restart. I think some say dynamic and some say static. The dynamic means you can apply it on the fly. The static means you have to restart the instance for that to take effect. In RDS, you have an option in the console to go and at any time restart or fail over an RDS environment. The restart effectively just reboots the instance in place. It doesn't fail over if you have a second node. I don't recommend that. I've seen customers get burned by that pretty bad from a crash recovery standpoint. If you've got a real large database with a bunch of VLFs and it takes forever to crash recovery to run, I've seen customers get into a lot of pain by just doing a restart. There's really no benefit. If you need to do, a restart, just do a failover or a full reboot with failover. Don't ever do just a restart on its own. If there's some scenario where you have to, I just don't recommend it just because I've seen customers get burned from the crash recovery standpoint. But anyway, that's a sidebar. SP configure, so I like that a lot from a standardization standpoint. A lot of the scripts you have your DBAs run after you do a build, you can kind of semi-automate through those parameter groups and such. So best practices, this is just standard, have limited access. You want to have public, this gets into the networking side. You want to actually have public facing and private facing. Public facing is where you put your jump boxes, your web servers, something like that. Private facing is where your databases live. You want to make sure that nobody that shouldn't have access does have access. We support SSL, forced SSL to secure the traffic in flight as well in RDS. So standard rules that you probably don't have to get into day to day in the life of a DBA, but they're important to be aware of. Like I said, we have encryption. We do the TDE encryption at rest. All the functionality you used to in the SQL Server in terms of doing column level encryption, all those kind of things, they're still exposed. It's still, a SQL Server product. RDS, there are some limitations, but encryption is there. You can create keys within AWS. You have some limitations like TDE and which keys you can bring from on-prem, but if you have those specific requirements, EC2 might be a better fit because you can have more flexibility in which keys you bring. And then SSL, you can't bring your own SSL certs. You can kind of get around it with some of our other networking tools, but that's kind of a little bit out of my area of expertise, but you can use SSL. And then kind of going back to least privilege, hopefully that's something that's near and dear to all of us. You have the same, you can create the same groups you're using today. You have your dev users in a group. If you do that Active Directory with trust, you can just give that same corporate AD group access to your RDS environment. Those security will just flow through, as it were. So you have that same things there. IAM is more appropriate for application development and such. That's our instance level security model within AWS. Access identity and access management. That allows you to give like a web server rights to do something over there. That's not really database level security. That's more of an application tier type thing. And then this is kind of my last slide of the night here. Just talking about, okay, we've talked about all these environments. How do I get my data into there? I have a whole different deck that talks about how to really do the replica migration into RDS. But this is just kind of a simple native backup and restore. That's generally my go-to. If you're ever on a call with an AWS person that tells you to use our database migration service, that's not good advice. Don't go down that road. It's great for going to a different database engine. It's not a good fit most of the time for a SQL Server to SQL Server. Those native backups are just easier by far. If you want to use the publishing wizard, you could. Okay, it's there. Database migration service, like I say, it's part of you basically create a skeleton of your database. Typically, it's going to like MySQL or Postgres, and you do a schema conversion, create an empty database. Then database migration service moves all your data across for a cutover to a different database engine. So it's great for that. Kind of overkill for SQL Server to SQL Server. A native backup, gets the job done a lot cleaner, and it takes everything. The migration service just takes your data and your DDL and such. You still got to move your users, still got to move your jobs, your logins, your operators, all that fun stuff. Marketplace, there's some other tools. That Cloud Basic was one example. You could use that as a migration tool, but there's lots. The marketplace is very cool. If you've got any kind of vendor relationship and you're looking to move a product into AWS and it's with a vendor, before you even attempt to look at what your manual options are, I always recommend go to the marketplace. If it's any kind of a large vendor, they're probably already there. They probably already have a prepackaged, here's how to migrate to AWS with our product. You can probably transfer your licenses even maybe. So marketplace is a great tool to be aware of just to see if you need it down the road. Replication, like I said, push subscription to RDS is supported. Everything else, not so much. But a push subscription, it can be a migration tool. It can be a lot of things. It doesn't do a lot of things well, but it does some things okay. But that's SQL Server. So those are some options. RDS is kind of limited. I have a different deck that talks about how you can do EC2 migrations as well. That's a lot more extravagant and other solutions that involve, availability groups and log shipping and all kinds of fun games. But RDS, by purpose of being managed, it's got a smaller subset of options. But that's we're trying to keep it simple in a lot of areas. And this is the database migration service. I just talked about that already. Why RDS? If you want SQL Server and you want to take some of the overhead away, you don't have any licenses, you don't want to start paying Microsoft. The other thing that RDS is good for are just the license included model. If you've got a product that is going to go end of life in 6 months, you just don't want to pay new licenses, but you've got to get it out of your data center, going at RDS or EC2 license included, rent those licenses for 6 months, either retire the products or move to a different open source database engine, and just walk away from that license cost without having to buy them outright. So it can be a good strategy if you've got products that have got a pretty short shelf life. You just got to get them moved, but you don't really want to commit to a huge investment for long-term resources. And that's my show. I apologize. I was 12 minutes over. I say it's because we started late. I would have been dead on if I hadn't microphone problems. But I went really fast. Usually this deck takes about 2 hours, so I tried to go fast to give you a kind of a flavor. RDS is valid to say, I'd probably see more customers go EC2 just because they own their licenses, and it's the tiering from a pricing standpoint is if you own your licenses, EC2, bring your licenses are cheapest, but you stay with SQL Server. If you go EC2 license included, it's the next cheapest. You're paying us for that license per minute per second rate, but you're not paying the managed cost. Then RDS is probably the more expensive of the three because you do have that managed component. We take care of all the things that you don't have to pay a person to do, like building the clusters and stuff like that. So depends what your use case is. Customers go all three. Depends what they need and what their specific footprint. And more often than not, customers have a little bit of everything. They don't go all RDS. Development lives in EC2 more often than not. They have some that are EC2, some that are RDS. Just depends what workload they're trying to migrate and what the best use case is. So, any questions? Yeah, go ahead.
I guess I must think. What you told me about. For DR, the asynchronous, what is that asynchronous? Seconds or seconds?
It depends on the regions you're selecting. Typically, it's good enough. I don't have exact numbers because every different region has different latency between the different region. You can monitor it. Typically, if you go from like North Virginia to Ohio, they're geographically closer, so that's going to give you one of your better DR strategies. And DR is generally a lot more than just what's the latency. Depends what your SLAs are. If you can take 3 minutes of data loss, then one option might be better. If you can take 2 hours of data loss, or you've got a RPO of 12 hours, then that metric becomes less relevant because you're just going to take native backups and ship them across to the second region. You don't need to pay for all the extra infrastructure. Oh yeah, yeah. I mean, so I can't say because every workload is different. You know, depending what your transactions are, what your rate of change is, how much data you're trying to push across the wire. Typically, you know, when you're trying to get to like under a 5-minute RPO, and that's, you know, a HA consideration more than a DR a lot of times. But if you've got a 5-minute, you know, typically I see most customers working just fine with an asynchronous DR copy. But you can and there's a difference. You know, once the data is there and hardened, doesn't necessarily mean it's been applied to the database yet, but it can be good enough. You know, so there's a lot of different things that come into is that an appropriate DR strategy? Is that the right amount of, you know, network capability? You know,
I mean, I get enterprise gives you the best DR, but
enterprise.
a lot of people like me, it's standard. RPO is 1 hour.
You know what? If you've got an RPO of 1 hour, frankly, you know, unless you've got other things to require. I mean, the key things of a DR environment is how fast can you stand it up? You know, do you have the budget to maintain that infrastructure all the time? If you've got you know, depending how large your database is, how long does it take to restore it? So if you've got, you know, an RPO of 1 hour, but you've got a 50 terabyte database, doesn't matter how fast we ship your backups, there's no way you're restoring 50 terabytes in an hour. So then you've got to have some kind of a asynchronous applying the transactions on the fly. Right. Well, yeah, but your RPO, you know, but typically if you have an RPO of 1 hour, your RTO isn't going to be 14 days. You know what I mean? You know, there's some kind of correlation between if you've got a really low RPO, then your RTO is typically going to be pretty low as well. But if you've got 14 days for your recovery time objective, it just, you know, there's a lot. Say I can't do a DR conversation justice. There's a lot elements. But if you've got if you've got an RPO of an hour, you know, if you're taking T-logs every 15 minutes and immediately shipping them to a different region, you can probably get those backups to a different place to make sure you're well within your 1 hour RPO. Whether you can stand up your infrastructure to meet your RTO requirements, you know.
I'm trying to think, it's like my RPO is 1 hour, but my boss says, well, I mean, it's not that common. Like, yeah, maybe up and querying it in 4 hour window.
Well, yeah, and that's where so then you can either look at, do I need to have a pilot light where my database instance is already stood up? You know, maybe I'm applying T-logs as they come in to that region. So then all I need to wait for is the last T-log, apply it, restore with recovery, and then I'm online. All the way to if you've got a smaller database, you know, you're shipping those logs, but all your infrastructure is just, you know, we talked about that CloudFormation or Terraform, that infrastructure is code. You know, part of your DR runbook is the first thing you do is fire off a script to provision all your EC2 and your RDS environments. Then you run your restore scripts. And if your RTO lets you, you're still going to maintain your RPO because you've got those backups in that second region. And if your RTO is generous enough, then you may be able to get all your infrastructure stood up in time to meet that RTO. And that's what, you know, do you want to pay for all the infrastructure and all the licensing? You know, licensing is a big thing. You know, you've got your software assurance that'll give you your passive node. If you've got all this, you probably have HA in your primary region. So you're using your passive use rights to license your passive node. You've got your production node, your passive node. That third copy that's in DR, you're gonna have to license that. I know Azure's got some other stuff going on. We don't have that capability. So that DR copy is gonna have to be licensed. But you're in the cloud. I generally, unless there's specific things I need to do, I generally don't recommend to customers that if they've got a 64-core behemoth machine over here for production, don't run that in DR. If you've got a RTO of enough, you know, of less than 30 minutes, or more than 15 minutes even, because you can take that machine you need to have 64 cores, whatever, to meet your production workload, run it as a 4-core, 16 gig of memory, enough horsepower to keep up with your asynchronous replication. If you're doing that, or if you're doing, if you're applying T-logs on the fly, your storage needs to be there, but your compute and memory can be drastically smaller than your production needs. It needs to be enough to keep up with your data flow so you can meet your RPOs, but it doesn't have to be large enough to meet production because you're not going to automatically fail over the DR anyway. The first thing you're going to do is get on a call with all the bigwigs and say, okay, can we go to DR? Can we go to DR now? What about now? What about now? When they finally say, okay, we're going to DR, you have plenty of time to scale up your DR node to the 64 core machine you need to support production workloads. So DR, there's always conversations, I've never seen a DR environment go over like that. There's always a conversation, because once you go over, you've got a whole bunch of other applications that need to go over with it, and then you might not come back for 6 months. So it's never a light decision as to whether we're going to DR in the real world. So plenty of time to scale up your DR node. So that's why I say there's a lot of factors. You don't have to have DR. Some scenarios, if they're running like a hot or near hot, they might need DR to be the same size as production. But more often than not, you don't.
Oh, my
Yeah.
it's good enough for government.
Yeah, that's very true. So yeah, there's a whole lot more about what's the right DR fit. Some companies that have like 2 data centers at the opposite end of town, they can probably get away with using 2 availability zones for their 2 different DR sites. Production and DR. I don't recommend that, but some companies say that's good enough. 2 regions generally doesn't cost you a whole. You have to have a little bit more infrastructure in place, but the cost is not significant to be in 2 regions versus 2 availability zones, and your DR strategy is much safer proposition if you're in 2 regions and 2 DR nodes. 2 availability zones. But you can slice and dice it however you want. That's why that's why these conversations are never simple. That's why if you're going to have these conversations, I always recommend my role. We're a free resource. We're pre-sales. We don't bill for our time. You can come we can come on site. This is not, I know I said it in sales, but I'm totally not sales pitching. I'm just telling you, if you decide to go down this road, make sure you have the right people in your rooms when you have these conversations. There's a whole lot of non-intuitive, creative ways to size your infrastructure in the cloud that can be much more cost effective than what you would do on-prem. On-prem, if I've got $100,000 and it's budget time, I'm going to buy the biggest box I can, because I know I don't get to go back to the well for another 3 years. So I'm going to stand up the biggest box I'm allowed to stand up, because that's all I got for the next 3 years. In the cloud, you don't take that approach. When we bring customers in, the first thing we do is reduce the size of almost all their boxes, because they were provisioned based on that 3-year budget cycle, not what they needed today. So we can save a whole boatload of money by just downsizing. Right sizing is what the fancy term is, but there's just a lot of mentalities that are based on prem that don't fit the cloud model, and that's where you can get a lot of benefits and extend that into your DR strategy. There's just a lot of options, and it's that's the cool part of the solutions architect job, is you get to mess with all these different architectures and talk to customers and say, well, you're doing this, and kind of fun and games like that. So yeah, so that's what I do all day, is talk to people about these kind of conversations. So it's fun sometimes. Yeah, so any other questions on RDS? No? Cool, yeah.
I'm wondering, get a picture of the economy is being.
Yeah.
That for the enterprise size databases on Amazon, many of them are in Madison.
Oh, I couldn't tell you that. Yeah, I don't know, to be honest. I know there's a very small, so I think I saw a number of maybe even 5% of the overall infrastructure is even in the cloud yet. So there's a lot in there, but there's a lot that isn't. Yeah, I don't know geographically. I support Central, so I have customers, all the 5 states around here, kind of thing. But we don't have a data center in Wisconsin anyway, so it'd be in North Virginia or Ohio. But yeah, I talk to customers with databases that are massive, in the terabytes, multi-terabytes, tens of terabytes. So it's all happening. It's just a case of what business problem we're trying to solve. What do they need? Do they have a bunch of manufacturing equipment on the floor and they need to be 20 feet away from it for performance reasons? We have some solutions. We have products that can be in your warehouse with your manufacturing machines to give you that super close information location, but they're not always a good fit for everything. So there are some scenarios where the cloud isn't ever going to be a good fit, but we're trying to make that window smaller and smaller by offering more things that you can do.
I wonder, roughly what percentage of the Amazon databases
AWS.
are,
I said AWS. I get yelled at for saying Amazon. It's AWS. They're a customer of AWS, just like all the others.
like what percentage?
I would say a lot. I mean, typically when we're talking to customers, they're not going to move their database tier and leave their web tier on-prem. It's a package deal. If you want to have any kind of performance, if you're moving your database tier to AWS, you're going to want your business logic, your end users, the web tier, all to be in the same vicinity for performance reasons. So I have seen it, but it's few and far between where a customer isn't going to move at least the whole application stack to AWS. They may leave some applications alone and pick others, but rarely do they split an application stack just because it doesn't make sense to have that level of latency. I mean, you can do pretty fancy networking between your on-prem and the cloud, an AWS cloud. We have things called direct connect, multi-gigabit connections. So you can get pretty fast connections. But just because, above and beyond the performance, there's so many other opportunities in terms of scaling your environments. If you need to have, Black Friday level website that's capable of Black Friday volumes, having the ability to scale up to 10,000 EC2 web servers when you need them, and then turn them all off the day after and not incur that cost in your on-prem data center is pretty powerful for those kind of, those scale of enterprise web applications. So let's say application stack typically moves with the database as one. So a lot of web servers are going to be in AWS because that's where the database went. As soon as the data has gravity, as they always say, as soon as your databases and your data are living in AWS, it makes the conversation to get everything there, very important, because all of a sudden anything that isn't in the cloud is dealing with that latency to talk to the cloud. So they say once your data once the data goes, everything else goes, because that's just the nature of using your data. It's the company's most valuable asset more often than not. So I don't know if that answered your question completely, but yeah, we do see most of the time application stacks, not just a single piece. I do see a single piece on occasion, but it doesn't make sense usually. Yeah, cool. So now you're familiar with AWS already, right? Is any of this new or informational?
Yeah, a lot of it was great. Thank you
Cool.
so much.
Oh, good. So, I never know the audience, especially some people are like, well, yeah, I know all this stuff. You got anything good?
I do have a client that uses, they've got a DynamoDB database, and then they're using Redshift for their reporting. Do you have a counterpart, like a solution architect, that deals more specifically with those solutions?
Yeah, you want to grab a business card?
I would love to.
Yeah. No. So we have, I forget the last number, 11, 12 different database platforms we support. So yeah, I'm SQL Server, Microsoft, but I have just people that do the same job as me for DynamoDB and our data warehousing and all that fun and games. So yeah, I can definitely hook you up.
Have you interacted much with Mode?
Mode.
It's just a tool to query for, yeah, I saw it for the first time on AWS, and got a couple customers using it. So I was curious, but I can probably connect
with BI tool.
It's just a query tool.
Oh, no, I have not come across it.
Okay.
But I'm sure somebody has. Yeah, no, we can definitely talk to those. Cool. Now, for those of you that really haven't had much chance to play with AWS, we do have a free tier. So when you're in the console, if you're looking to spin something up, and obviously you can spin up an Express edition, which is a free copy of SQL. You can use Developer Edition. There are free tiers of super small machines if you wanted to play with some things in RDS, or just when you're in the console, you'll see a lot of things that say free tier. They're not powerhouse machines by any mean, but if you want to just kind of get your feet wet, that free tier can give you it's not as great as Azure credits. I wish it was, but the free tier gets you there, gets your feet wet, gets you a little bit of area to kind of play with some of this stuff and to see how the console comes together. Yeah, so the free tier, it spins up boxes that have Windows installed and such, and you can just go pull down the ISO for Developer Edition and install it.
What I'm thinking is I would take prints from this over.
Well, that would probably tip over on these small databases. I mean, that's a big database. Yeah, they're like half a core or one core, and you're paying for. You probably have to pay for the storage.
That's over to overflow on there.
You can put all the wins on there. You can put North Winds on there, on all the wins, whatever they call that database. Oh, there you go. Yeah, give it a try. I say I do not make any guarantees about performance, but that kind of stuff. I mean, yeah. But the nice thing is you could spin it up for a couple hours and do some playing, and then size it back down to the free tier afterwards. Just ask for your boss's credit card, and what's wrong with that? Frankly, if you're working for the state, they probably already have something running in AWS. You just need to get access to it. In reality.
I think you're right. I think Department of Corrections does have it.
Yeah.
I only support it on also.
You got to skill up, man. You got to get, start asking questions. Hey, well, who do I get access to? Because they probably already have, like, the free tier will get you so far. You're not going to spin up Enterprise Edition on the free tier. So, getting access to a larger sandbox that typically large organizations will host for the development team, that's where you get the benefit. Hey, we got a bunch of stuff. reInvent's going to be online for a bunch of stuff as well this year. I wore my reInvent t-shirt just to give us a free plug. But, we have a 1-day boot camp this year at Pass 2. I don't think it's free, but it's a lot of information. There's a whole YouTube. We got so many videos on YouTube, so many, labs that you can kind of get access to. There's a ton of information out there. I mean, the free tier is nice, but even if you just, watching YouTube and looking at some of the blogs out there and pre-formatted these cloud formation that create a whole environment, there's a lot of stuff out there, a lot of ability to kind of have some space to do labs and sandboxes and we come in all the time and say, hey, we'd like to see about this, this, and this. So people will come in, we'll make a whole day of it. We'll spin up a whole bunch of lab environments so you can kind of get on and create massive databases and do what you want to do on our dime. Then we delete it all at the end of the day. And, it's just a great, now you've seen the RDS presentation, so don't ask for that one to come on site because you've seen it now. But, come on and talk about DynamoDB or Redshift or, EC2 or any variation thereof. And then the nice thing about those is they bring labs. They bring you the ability to have a guided play with various pieces of technology for any of the stack you see in AWS. So it's if you can convince your manager or just make it kind of a good way to get. I always call it free training. It's really what it is. Come in.
I'll let you know.
I can, if SQL, I can do a half day. I can do a whole lab environment. I just got, we can do all that kind of stuff. My sandbox is pretty big. Yeah. And, it's kind of like I said, the data is the first part, but you can get a little chink in the armor, get something moved over there, and all of a sudden, your administrators that have lived and breathed going into the data center to plug wires in their firewalls and get up at 3 a.m. and wait, I can do all this from here. Get some advocates on the networking side and the security side, and all of a sudden things fall into place. But it's kind of, it's a lot. There's a lot of AWS. It's unfortunately, I say a good thing and a bad thing, but we have 6 different ways to solve every problem and a million tools to get there, and it can be overwhelming. So that's why we try and kind of create the simple path forward. If you're trying to solve this problem, this is what most customers do. That's what I try and do is, when they're talking about, how do we do this? I'm like, well, this is what I see customers do. This is where I see customers fall flat on their face. Don't do that. So that's kind of the conversation I try and bring. I try and pretend I have some background to kind of give some, some stability to the conversation, some real world examples. But was you gonna bet my coffee's completely cold? Yep. That's what I get for talking too much. That's why I had a Coke too. So hopefully it was informative. If you have any other questions, like I say, this is RDS. We do the same thing on, networking, deeper dive on HADR, deeper dives on just migration strategies, deeper dives and just SQL Server on EC2. There's a whole bunch of other performance tweaks. If you're looking at that path, there's a lot more bells and whistles and levers and dials on the EC2 world to make it run faster and cheaper. RDS is kind of I don't say a black box, but there's less levers. You can pick the storage tier, but that's all you got. EC2, you can pick 5 different storage tiers and put your really slow database on hard disk and your fast databases, the hotspots, your fast, hotspot tables on different storage tiers again. You just have a lot more flexibility. So there's a whole presentation about that. That's just SQL Server. I mean, we have dozens of people, hundreds and hundreds of people that do this same job for other architects if you've got other needs in your company above and beyond SQL Server.
I've got an HA question.
Mm-hmm.
In in healthcare, some of the big vendors, when they are on-prem, they'll have their production databases will be like they'll put their production database on one node and then they'll run all of their non-production environments on the other node. And then when they fail over, the non-production environments get booted. Does that concept apply, or could that apply with this when you showed the synchronous? Like, I don't know if that would work the same way.
You conceptually could do that architecture. You don't really need to, honestly. But that doesn't really apply here, because what we're doing there is we're providing a passive copy of your production data. And DR isn't, no, the development isn't really running around there. It's on a different set of stack. You're using developer edition, so you don't really need to worry about trying to save on those license costs, because developer edition is free. Conceptually, yeah, you could architect that. I do a fair amount with healthcare, but I haven't really seen the need for that approach. Generally, it's always interesting. Like, I worked in healthcare for a number of years, and I hear people say, well, our dev environment isn't important. Let's just back that up once a week. Like, you've got X number of developers at 40 hours a week. How much do you pay those guys and gals? And then you want to just throw all their work out the window because you couldn't be bothered to back it up. I'm like, yeah, no, that's not how that works. So I've heard it. Thankfully I don't hear it every day, but people think development environments are like, yeah, just throw them away when we need them. No, that's not how development works. It's way more critical than that. Way more expensive to replace. So that's why that kind of architecture kind of makes me cringe a little bit, because if your development environment disappears, what's the team going to do on Monday morning? Like, what? We got to redo all that? No. So you could, with just the cloud initiatives and the ability to be creative, I just think there's better ways of architecting that to be as cost efficient, but with much less developer downtime and loss of data. You mean if you're backing up, if you really had to, I guess you could make sure your backups are good and throw it. But yeah, there's other ways of doing things to get to a similar end goal without being as destructive about your development environments. I think you've heard that argument too about development environments. You're shaking your head. Yeah, exactly. Yeah, and I hear it. I'm like, well, let's just go back at one. I'm like, because that's the thing. I come in, before I worked at AWS, because now I'm more like coming in and telling people how to do things. But prior to that, like 6 years before that, I was coming into environments and doing health checks and telling them what they were doing wrong, but without a nicer face on it, because I wasn't sales. And backup strategies. I mean, really, I've seen people lose their jobs over backups not working. So I like to make sure that stuff's down pat, because I've seen the results of it not being. Thankfully, not firsthand. But yeah, so yeah, there's always things. And like I said, the people that think managed services take care of the reindexing, so they don't bring the reindexing strategies, and then they wonder why SQL. I always say SQL Server is a great product. You can throw a vanilla installation, throw some databases on there. It'll work great for a while, and then eventually you'll hit that tipping point, and things will just fall over. And that's when Brent makes a whole bunch of money, and SQL Skills makes a whole bunch of money, and I keep getting paid the same because I'm sales. But yeah, it's just there's a lot. SQL Server is such an easy product to get out there that there's a lot of misunderstanding and a lot of opportunity to educate. So that's why SQL Saturdays are cool. I haven't talked to a SQL Saturday in a long time, but hopefully sometime soon. I haven't frankly done a user group. I had one scheduled, I think, to talk, maybe even here. And then I got hired at AWS, and AWS has some pretty strict policies about what you talking about their product. Like, I had a whole what SQL Server DBAs need to know about AWS that I used to do before I worked at AWS. And I'd done it at a couple of different SQL Saturdays. And I was prepared I was either here or some other SQL Saturday, and I was all set to present it. And then I learned about the requirements of speaking when you're an AWS employee. I'm like, oh, I can't actually speak about this for a while until I get some things taken care of in terms of internal training. So they're very, we have a very we want to make sure that when we're answering questions, we're, making sure that we accurately represent our position. So we want to make sure that, our messaging is valid and correct, and, you don't talk to 5 different people and get 5 different answers, because some vendors do that and it doesn't really leave a good taste in your mouth. So we like to make sure that we've got, important answers to questions answered consistently and correctly. And, so anyway, so I haven't done these kind of a presentation in a while. I'm probably rusty. I've done a lot of presentations on Zoom and Teams and Chime, but yeah, it's different to actually get and see real people staring back at you. Then the pressure's on. Can't mess this up too bad. Yeah, thank you.
The most important question, how do you pronounce your last name?
Ekins.
Thank you.
Yeah. 2 years and they still butt you on every other call I'm on. Yeah. Joys of, I don't think it's a competition.